Hello, welcome back into my channel. In this video, I'm going to discuss how we find the solutions of an exam paper of IB on May 2022, AA High Level, Paper 3. Okay, let's start with number 1. A polygonal number is an integer which can be represented as a series of dots arranged in the shape of a regular polygon. Triangular numbers, square numbers, and pentagonal numbers are examples of polygonal numbers. For example, a triangular number is a number that can be arranged in the shape of an equilateral triangle. The first 5 triangular numbers are 1, 3, 6, 10, and 15. The following table illustrates the first 5 triangular, square, and pentagonal numbers, respectively. In its case, the first polygonal number is 1 represented by a single dot. So you could see this table consists of triangular numbers, square numbers, and pentagonal numbers. And look, the values 1, 3, 6, 10, 15, 1, 4, 9, 16, 25, and so on. 1, 5, 12, 22, 50, 35, and so on. And these are the geometric representation. Okay. For an R-sided regular polygon where R element of integers and R greater than or equal to 3, the end polygonal number PRN, this is the symbol, is given by PRN equals R minus 2n squared minus R minus 4n over 2, where n element of integers. Okay. Hence, for square numbers, P4n equals 4 minus 2n squared minus 4 minus 4n over 2 equals n squared. So this is if r equals 4, so this function will be n squared. Okay. Questions A1. For triangular numbers, verify that P3n equals n times n plus 1 over 2. So we are going to prove that if r equals 3, the functions will be like this. Okay. A1. That according to this formula, that if r equals 3 will be P3n 3 minus 2 n squared 3 minus 4 times n over 2. Okay, I'm going to scroll down. Okay. So it will be n squared plus n over 2. Or we may simplify, becomes n times n plus 1 over 2. 2. The number 351 is a triangular number. Determine which one it is. Okay. Triangular number, it means r equals 3. So P3n equals 351. So we're going to find how much n, right? Okay. So P3n equals this one, this fraction, n squared plus n over 2, 351. The next step is multiply by 2. It becomes n squared plus n, 702. Okay, 702. So it becomes n squared plus n minus 702 equals 0. So that we are going to factorize n minus 26 times n plus 27 equals 0. So n equals 26 or n equals minus 27. So we're not going to using this, but the solutions on the n equals 26. This is the solution. B. Show that P3n plus N plus P3 n plus 1 equivalent with n plus 1 squared, right? Firstly, P3n, P3n is 1, okay? N squared plus n over 2. And then P3n plus 1, n plus 1 squared plus n plus 1 over 2. So we're going to find the sum of P3n plus P and P3n plus 1. Means this, okay, this fraction plus this term over 2. So it's gonna be same denominator. So n times n plus 1 plus n plus 1 squared plus n plus 1 over 2 will be factorized. N plus 1 times n plus n plus 1 plus 1. Okay, it is n plus 1 times n plus 1 plus n plus 1 over 2. So n plus 1 times 2. Okay, 2 n plus 1 over 2 divided n plus 1 squared. Proof that this term equivalent with this term. And to state in words that what the identity given in part B1 shows for two consecutive triangular numbers. Okay, 2, the sum of triangular number and n plus 1 is, yeah, n plus 1 squared. Yeah. So the sum of triangular numbers n and n plus 1 is n plus 1 squared numbers. Okay. For n equals 4, sketch a diagram clearly showing your answer to part B2. Okay. If n equals 4, n equals 4, it means if n equals 4, so 16. Okay, 16 plus 4 over 16 plus 4, 20 over 2, 10. Oh, okay, so, but we're going to if n equals 4, so it would be 1, 2, 3, 4. Okay, then I'm going to use another color. Okay, so 1, 2, 3, 4 as well. 1, 2, okay, 1, 2, 3, 4, and 1, 2, 1, 2, 3, 4 as well. Okay, so it will be this 1, 2, 3, then 1, 2 like this. After that, it will be like this 2. Yeah, yeah, 25. Okay, so that 8p3n plus 1 is the square of an odd number for all n element of integers. The n pentagonal number can be represented by the arithmetic series p5n equals 1 plus 4 plus 7, and the term is 3n plus 2. Okay, so 8 p3 n equals 8 times yeah, n plus 1, n times n plus 1 over 2 equals, I did 4 times n squared plus n, and will be 4n squared plus 4n. Factorize to n plus 1 squared. Okay. So 2n plus 1, of course, is odd number. Yeah. Right. Oh, this is supposed to be minus 1 here. Yeah. But this is the odd number. Okay, next. This one C, and then D, and so that P5n plus of n equals n times Pn minus 1. Okay, over 2 for n element integers. So P5 n are 1 with plus 1 plus 4 plus 7. Okay, 3n minus 2. Okay, so it means a equals 1 and the difference a or u1 is 3. Substitute into this equations, this formula P5n of n times 2a plus n minus 1 times d. So it's gonna be half n times 1, 2 plus n minus 1 times 3. This becomes a half n times 2 plus 3n minus 3. N times 3n minus 1, or n times 3n minus 1 over 2, like this. Yeah, this one, yeah. Or we may write 3n squared minus n over 2, but we have to prove like this. That proof that P5n equals n times 3n minus 1 over 2, this one already. E, by using a suitable table of values or otherwise determine the smallest positive integer greater than 1. That is both a triangular number and pentagonal number. Triangular number and pentagonal number. So a polygonal number Pn can be represented by this series. Right. What I'm going to find a number include of triangular number and pentagonal number. Right. If we create the table, be like this. Okay, it's N and M for the triangular and for the pentagonal N, while triangular N. So this is 1, 2, 3, 5, 6, 7, 8. I'm going to create until 20. Let's we are going to continue at the space. Okay, but we're going to find based on the formula that Pn equals Pn equals n squared plus n over 2, and P5 n equals, m times 3m minus 1 over 2. Okay, and the number are, this is if we substitute 1 here, will be 1. If 2, will be 3. If 3 substitutes into these equations, will be 6, 10. If 5, 15, 6, 21, 7, 28. If 8, 36. If 9, 45. If 10, 55. If 11, 66. If 12, 78. If 13 is substituted into these equations, it will be 91. If 14, 105. If 15, 120. If 16, 136. If 17, 153. If 18, 171. If 19, wait, I have to create a new one here to continue. Okay. If 19, I just until, wait. Okay. Nineteen, 190. If 20, 210. Okay. Okay. Then how about if P5M, if m equals 1 and substitute into these equations, it will be 1 because 1 times 2 over 2 equals 1. If m equals 2, This is 5. If 3, 12. If 4, 22. If 5, 35. If 6, 51. If 7, 70. If 8, 92. If 9, 117. If 10, 145. If 11, 176. If 12, 210. So look that the solution, the number is what? 210. So 210 is a triangular number and a pentagonal number. So if the solution is 210, it means the values of n equals 1, 12, while n equals this one, 20. All right. F. Use mathematical induction to prove that PRN equals r minus 2n squared minus r minus 4n over 2, where n element of integer. Okay, the first step. If n equals 1, we are going to prove that if n equals 1, that this functions as well equals 1. So PR n equals, firstly, this for this function m equals 1 to 1. Yeah. 1 plus 1 minus 1 r minus 2. And this is equals 1 plus 0 because this is 0, 1 minus 1. And the second function, this one, sorry, this one, if it is n equals 1, so this equation being r minus 2 times 1 squared, r minus 4 times 1 over 2 becomes r minus 2 minus r plus 4 over 2 minus 2 over plus 4, 2 over 2 equals 1. So it's 1 as well. Okay. Second step, assume that if n equals k, the statement is correct. It's true for PR k equals r minus 2 times k squared, r minus 4 k over 2 equals this one, this equation, 1 plus k minus 1, r minus 2. Okay. This is useful for the next step, for the third step, that if n equals, n is, that the statement correct for n equals 1. Now, if n equals 1, first this one, for this equation, PR k plus 1, sigma m plus equals 1, 2k plus 1, 1 plus m minus 1 times r minus 2 plus 1 plus k plus 1 minus 1 times r minus 2. So cancel 1 because 1 minus 1 equals 0. So it becomes 1 plus m minus 1 r minus 2 plus k times r minus 2. Okay. Then this is uh, a PR. Okay. There's one here. Sorry, I forgot this one. This is PR, a PRK. Sorry, if this is K, sorry, this is K, actually it's K. Goes from K to K plus 1. Okay, so it means this is K. Okay, so if that is K, okay, that PRK as well equals this one, 1 plus K minus 1, R minus 2. So we can state that this is PRK. PRK plus K times R minus 2. It's 1. So it means PRK as well equals 1. So we can write that R minus 2, yeah, K squared minus R minus 4K over 2 plus, we can set being the same denominator, minus 2K, R minus 2 over 2 plus 2 over 2. Then this is R minus 2K squared minus R minus 4K plus 2K, R minus 2 plus 2 over 2. And after that we factorize, R minus 2 times K squared plus 2K minus R minus 4K plus 2. over 2. So it becomes r minus 2. We will add 1 here because we're going to factorize. Plus 1. That should be minus r minus 2 minus this term minus r minus 4 k plus 2. And then becomes r minus 2 times k plus 1 squared minus r minus 4 because minus plus 2 equals 4 minus r minus 4 k over 2. Then let's factorize again. This part will be r minus 2 k plus 1 squared minus r minus 4 times k plus 1 over 2. Yeah. So this is the result. So now we are going to prove that this PRK well equals based on this formula. Yeah. PRK plus 1, I mean. If PRK it is r minus 2 k squared minus r minus 4k over 2. If p up k plus 1 will be r minus 2 times k plus 1 squared minus r minus 4 times k plus 1 over 2. You may compare between this one and this one. Yeah. They have same result. Right. That is number 2. In parts A, B, and C, let R equals 1 and A equals 4 and B equals 1. Consider the equation z minus 1 times z squared minus 8z plus 17 equals 0 for C element of this number, complex number. Given that 1 and 4 plus I are roots of the equation, write down the third root. Verify that the mean of the two complex roots is 4. Okay, firstly, this one. I'm gonna change the color. Right. So z minus 1 times z squared minus 8z plus 17 equals 0. we can writing like this, z minus 1 factorize becomes z minus 4 plus I times z plus, z plus z minus 4 minus I equals 0. So to this factorization that we can state that z equals 1 and then z equals 4 plus I and z equals 4 minus I. So the third root is this one. Z equals 4 minus I. Okay. Verify that the mean of the two complex roots. So two complex roots are 4 plus I and 4 minus I. So we are going to find the mean. It means 4 plus I plus 4 minus I divided by 2 because we're going to find mean. So mean 4 plus I plus 4 minus I over 2 will be 8 over 2 equals 4. Consider the functions f(x) equals x minus 1, x squared minus 8x plus 17 for x element of real numbers. Show that the line y equals x minus 1 is tangent to the curve y equals fx at the point A, 4, 3. Sketch the curve y equals fx. Okay, and the tangent to the curve at point A clearly showing that the tangent crosses at the x-axis, right? So for part B, fx equals x minus 1, x squared minus 8x plus 17. So if we calculate, it's going to be x cubed minus 8x squared plus 17x minus x squared plus 8x minus 17. It becomes x cubed minus 9x squared at 25x minus 17. And the derivative of that function is, because we have to find the derivative first because we are going to find the tangent. The derivative of this function is 3x squared minus 18x plus 25. So if x equals 4, because of this coordinate point, 5 plus 4, so we found this is 16. 18 times 4 plus 25 equals, I'm going to calculate first with my calculator, it will be 48 minus 72 plus 25, it is 1. So it means m, or the gradient, equals 1. If gradient equals 1, based on this rule, this formula, y equals y1, how to form the straight line equation? This is x1, y1, and this is m. So this equation being y minus 3 equals 1 times x minus 4. So it means y equals x minus 4 plus 3. So it means the equations of straight line is x plus x minus 1. Sorry, this the equations of the tangent. Okay. So y equals x minus 1 is the tangent equation. Tangent equation to the curve through A. Yeah, this coordinate point 4, 3. Right. Now, part C, we're going to sketch. But to sketch this curve, the cube curve, I'm gonna find the extreme point, or the maximum and minimum point. So it means we have to find the first derivative. So the first derivative, I'm going to use this one. I'm going to use this first derivative. Okay, this derivative is x plus 3x squared plus 25. So assume that it is equals 0. So it means a equals 3, b equals minus 18, and c equals 25. It's hard for me to factorize, so I'm going to find x1 and x2 through this formula. B squared minus 4ac over 2a. So x1 and x2 equals minus, or being plus 18 plus minus minus 18 squared minus 4 times 3 times 25 over 2 times 3. Okay. So it is x1 equals 18 plus square roots. Wait, this is 324 minus 300 over 2. So 18 plus square root 24, 4.9 over 2. 3.8. So the first coordinate point, uh, oh wait, yeah, this x1, we are going to find after this. So the first coordinate point, yeah, point 8, substitute into this function fx equals, okay, that function, x cubed minus 9x squared plus 25x minus 17. Okay, substitute into this function, and we found that fx equals 3.8 cubed, 9 times 3.8 squared, 25 times 3.8 minus 17. I'm going to calculate first. Okay, it is 2.9. So the first coordinate point, is 3.8, 2.9. And this is the minimum point. Okay. The second x, so x2, is 18 minus square root 24 minus 4.9 over 2. And it is 2.2. So next we found if x equals 2.2, so fx equals, substitute into this function, this one, this function. So f2.2, 2.2 cubed minus 9 times 2.2 squared plus 25 times 2.2 minus 17. Oh yeah, this one, 5.1. So the coordinate point is 2.2, 5.1. And this is the maximum point. Right. So we're going to sketch. Okay. Y-axis, x-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So first we have to find that this that the minimum point 3.8, 2.9, 3.8, 2.9, 3.8 is 3.8 8 and 2.9 around here. So wait, I'm going to use another color around here. That's the minimum point, and then 2.2, 5.1, 2.2, 5.1, 2, 3, 4, 5 around here. Okay. Right. What else? It says that sketch the curve y equals fx and the tangent to the curve at point A, clearly showing where the tangent crosses the x-axis, it means we have to find that if y equals crosses at the x-axis happening when y equals 0. When y equals 0, it means x equals x cubed, or yeah, x cubed minus 9x squared plus 25x minus 17 equals 0. As you know that actually these equations, this term came from this term first, x minus 1, x squared minus 8x plus 17 equals 0. It means x equals 1. This x equal, if x minus 1 equals 0, it means x equals 1. So the coordinate point 1, 0. It's 1 here. Okay, so we could sketch that probably like this. I'm going to sketch this. Nice. Wait. Yeah, like this. Okay, intersection to intersect to the x-axis. Then this. Yeah. And as well, we are going to sketch tangent equation. Tangent equations is y equals x minus 1. So yeah, this one. Y equals x minus 1. If y equals x minus 1, y equals x minus 1, it means if let y equals 0, if y equals 0, so x minus 1 equals 0, so x equals 1, and the coordinate point 1, 0. And you know that this tangent through 4.3. It's not to 4.3 through this coordinate point 4.3. So coordinate point A on this curve 4.3 around here. Okay, around here. Because 4.3, this is comma 3. I mean 4.3. So it will be like this. It's yeah. That's the straight line. The straight line tangent. Consider the function gx equals x minus r times x squared minus 2ax plus a squared plus b squared. For x element real numbers where r a elements real numbers as well, and as well b elements of real numbers and b greater than 0, so that derivative gx is its expressions, and secondly we are going to answer these questions, right? First is one, show that derivative of gx is 2x minus r, x minus a plus x squared minus 2ax plus a squared plus b squared from this function gx. Gx, x minus r times x squared minus 2ax okay. We're going to find the derivative of these functions. If these expressions u and this expressions p, so it means we're going to find through this formula that if u times phi will be u phi derivative phi plus u derivative times phi. So it's going to be, if this is u, okay, here, derivative u, 1, and if this expression is phi, derivative of phi, the x minus 2a. And then derivative x will be u times derivative phi x minus r times 2a at 2x minus 2a plus 1 times, it means x squared, 2ax a squared plus b squared. So it's gonna be 2. Yeah. Now factorize this, 2 times x minus r, x minus a, then plus x squared minus 2ax plus a squared plus b squared. So prove. Do this one, the second. The derivative g is one, but we are going to find how about uh, if g if x equals a, yeah, if x equals a, if x equals a will be like this, 2 times uh, a minus r a squared to a squared plus a squared plus b squared. This is 0. So it's going to be 2 times 0. So cancel this derivative a equals b squared. Okay, now we're going back to a gx, gx1. So it means if x equals a, these functions will be a minus r, okay, a minus r times a squared to a squared plus a squared plus b squared. So it is, cancel this, a minus r times b squared, right? Now, if GA equals 0, if GA equals 0, so it means this expression equals 0, right? So a minus r equals 0. The implication is a equals r. So there's a point at x-axis. We will continue here. Yeah, it is a point at x-axis at the point A is A, comma G. A being on R, A equals R, 0, because it's GA equals 0, this one. Yeah, right. The equations z minus r times z squared minus 2az plus a squared plus b squared equals 0 for z elements. C has roots r and a plus minus this imaginary number where r and a elements r and b elements r b as well greater than 0. So deduce from the one that the complex roots of the equations, these equations can be expressed as these expressions, right? So gz equals c minus r times c squared minus 2a z plus a squared plus b squared, right? So just now we already found it that derivative ga equals b squared. For note here that derivative ga equals b squared. It means b equals square root square root derivative ga, yeah, plus minus here. Now, if this equals 0, if this one equals 0, this expression is equal 0, means we're going to find the roots equals 0. We can state that z equals r, or c squared minus 2a z plus a squared plus b squared equals 0. And that's the second possibility. The first one is zr equals 0, or this expression is equals 0 based on quality equation that a equals 1, b equals minus 2a, and c equals a squared plus b squared, right? Now we're going to find uh, the roots of z, so will be 2a plus minus b squared. It means 4a squared minus 4ac, 4 times 1 times a squared plus b squared over 2 times 1. It's going to be 2a plus minus square roots 4a squared minus 4a squared minus 4b squared over 2. So equals 0. It becomes 2a plus minus minus the root minus 4b squared over 2, or 2a plus minus 2 times minus 1, square root minus 1, b squared over 2. And it is divided. So a plus minus minus 1 times b squared. So it is a plus minus, this is I, And recall that b squared equals derivative. Yeah. Or a plus minus square root derivative g a I. This. In the Cartesian plane, on the Cartesian plane, the point C1 and C2, S1 represent the real and imaginary parts of the complex roots of the equations. These equations, following diagram shows a particular curve of the form, yeah, this function, and the tangent to the curve at the point a comma at, the curve and the tangent both intersect the x-axis at the point r minus 2 comma 0. The points C1 and C2 are also shown like on this diagram. So C1 reflecting to C2 and the reflector is the x-axis, right? F. Use this diagram to determine the roots of the corresponding equations of the form. So on these equations, okay, state the coordinates of C2, right? So at a comma at, a and at, a is on the coordinate point A. So it means x equals a, y equals at. So, and then as well r, 1 minus 2 0. So it means r equals minus 2. Okay. Then these functions, gx, x minus r times x squared to ax, a squared, b squared. So it means, yeah, b right. Yeah, if you look this one, that b equals 16. Yeah, because this b equals this one 16. Compare this 16 and b squared. So b squared equals 16. Right. Then b equals square root 16, or b equals 4. Next, GA equals p squared times a minus r. Then GA, because b squared equals 16, a minus r equals 2, minus 2, it means there's 2 here. And if y equals 80, this 80, so it becomes 80 equals 16 times a plus 2, or a plus 2 equals 80 over 16, or a plus 2 equals 5. So a equals 3 because 5 minus 2. Then z minus r, c minus r, I mean, c minus r times c squared minus 2az. This equation is from this one. Okay. Plus a squared plus 16 equals 0. And next we are going to find the roots for 0. So there are the two possibilities, z minus r equals 0, or this expression is equal 0. So this is a equals 1, b equals minus 2a, and z equals a squared plus 16. So the roots z equals minus oh, 2az, I mean plus, becomes plus 2a, and then plus minus square root 4a squared minus 4 times 1 times a squared plus 16 over 2. 2 times 1. This becomes 2a plus minus, cancel, square root minus 16 over 2. Minus 16 is minus, minus 1. Square root minus 1. That means 2a plus minus 4i over 2. And so it becomes, I'm going to move here, a plus minus 2i, already divided by 2. So a equals 3, this one. It is, just now this 64, sorry, 64 here. 64 because 4 times 16. So this is 8. And this is, sorry, I'm going to fix it first. Minus 64. This is 8, right? So that means this is 4. Because 8 divided by 2, it becomes 3 plus minus 4i. Then z minus r equals 0. So there are two possibilities from this. Z minus r equals 0. So it means z equals r. R how much? R equals minus 2. So, all right. Let's continue. Show that the x-coordinate of P is this expression. You are not required to demonstrate a change in concavity. Okay. Hence, describe numerically the horizontal positions of point P relative to the horizontal positions. Horizontal positions. Okay. Of the points R and A. Right. So first one, firstly, it's one that these functions gx equals x minus r times x squared minus 2ax plus a squared plus b squared. And the derivative is now 2 times x minus r times x minus a plus 2 plus x squared, I mean 2ax plus a squared b squared, right? And the second derivative is still using u times phi. U times phi for this one is going to be 2 times 1 times x minus a, 1 times x minus r plus 2x minus 2a. So it becomes 2x minus 2a plus 2x minus 2r plus 2x minus 2a, and it becomes 6x, and that's minus 2r, and then 4, 4a, okay? Now, if the second derivative equals 0, we gain the equation 6x minus 2r minus 4a equals 0. Right. I'm going to divide it by 2 or multiply it by half. So it's going to be 3x minus r minus 2a equals 0. So becomes 3x equals 2a plus r, or x equals 1/3 times 2a plus r. Okay. Next, 2 we have more space. I'm going to the horizontal, it means like this. R, then A is point is R, and A here, and B around here, for example, P with coordinates 1/3 to A plus R. Okay. Now we're going to find if this distance, I'm going to name D1, and the second distance here, so we're going to find the first distance, or D1. D1 equals to 1/3 times 2A plus R minus this R. So we gain 2/3 A plus 1/3 R minus R becomes 2/3 A minus 2/3 R, or 2/3 A minus R. And the second derivative, the second distance is A, therefore, because this is A from this point to this point, A minus 1/3 times 2A plus R. So A minus 2/3 A minus 1/3 R becomes 1/3. 1/3 A minus 1/3 R, or 1/3 A minus R. So next, this the distance between R and P is 1, and distance P and A is 1. Right. Now, distance, we could state that distance R to A is 2/3 A minus R plus 1/3 A minus R equals 3/3 A minus R, or equals A minus R. This. Yeah, the accumulations of D1 plus D2. Then if we compare RP to PA, it is 2/3 A minus R to 1/3 A minus R. So it's gonna be 2/3 to 1/3, or 2 to 1. So D1 or segment RP is twice than D2 or PA, segment PA, like that. Consider the special case where A equals R bigger than 0, sketch the curve. These functions for A equals R equals 1 and B equals 2. For A equals R, B greater than 0, state in terms of R. Okay, in terms of R, the coordinates of P and A, right? One, we are going to sketch the curve. It means, yeah, y equals x minus r times x squared minus 2ax. This will be squared. So if we substitute this number and this number, it becomes x minus 1 times x squared 2x plus 1, 5. Yeah, plus 5. Right. So the intercept point at x-axis happening when y equals 0. And y equals 0, so there are two possibilities, but we are going to find this one, x minus 1. So x minus 1 equals 0. So x equals 1. So the coordinate point 1, 0. Intercept point at y-axis happening when x equals 0. When x equals 0, y equals negative 1 times 5, negative 5. So 0, negative 5. So we are going to sketch. If this sketch becomes like this. Y, x is 1 and negative 5 around here. Okay. And if we sketch, it will be like this. Yeah, oh, sorry. Around like this. Yeah. Because this is the graph of cube. Yeah. Cube equations. Right. Next. Wait. I need electricity for my computer. Right. Secondly, we are going to find coordinate point P and A in terms of R. So the coordinate point P has a coordinate x equals 1/3 times 2a plus r. Okay. It is 1/3 times 2r plus r. Why? Because a equals r. A equals r is 1. So, answer. A equals r. So it is 1/3 times 3r or equals r. So x equals r. If x equals r, we're going to find y. Y equals g r. It is r minus r. Substitute into this equation. Okay, these equations r minus r times x squared minus 2ax plus a squared plus b squared equals 0. Why? Because this is 0. So the coordinate point P is r, comma 0. Next, we're going to find coordinate point A. At point A, when A is A, comma G, A. You could see this one. Sorry. This one. A, comma G, A. Yeah. You can see at the upwards that A is A, comma G, G, A. If A equals R, means GR. This is the X. Yeah. If X equals A and A equals R, so you could find Y. Y is, so the coordinate X is R, so coordinate Y is GR. GR, just now we already calculated here, GR equals 0. So the coordinate point A is R, comma 0.